Picture a box with everything your app needs to run: code, libraries, and even the OS, all synced into a single package, ready to run, deploy, and launch. This is the concept of a container. Containers are fast, portable, isolated, and provide consistent environments that can be launched in seconds. After learning about them, you'll wonder how you ever managed without them.
But that's just a VM.
Firstly, Ellie, please sit down. Secondly, no, not exactly. Both virtual machines, VMs, and containers create isolated environments to run an operating system. But containers are far quicker to create and generally consume fewer resources. If you imagine a spectrum with VMs on one end and native applications on the other, containers sit somewhere in the middle. VMs rely on a hypervisor to simulate hardware, tricking the system into thinking it's running on physical machines. Containers, on the other hand, have a more direct relationship with the host system. They emulate only the minimal file system they need while leveraging the host's kernel. The kernel is not that one. This one. The kernel is the core of every operating system. It acts as a bridge between software requests and hardware actions, managing critical functions like CPU usage, memory allocation, input, output operations, file systems, and process control. So how does this all help us as developers? Now that we have an OS at our fingertips, we now have the ability to work in multiple environments simultaneously without overloading their local systems. For example, you can maintain an older application with its original operating system and dependencies while simultaneously working on a cutting-edge project using the latest tools, all without worrying about conflicts. Containers also solve the infamous "it works on my machine" problem. Since a container is a self-operating machine, it will behave consistently whether it's running on your machine, your colleague's machine, in the cloud, or on the server. With the basics covered, let's see how to get a container. First, we'll need a container platform. This provides all the tools required to build and run containers. For this video, I'll use Docker, as it's the most widely supported option. Containers are built from a base file system and metadata, packaged into what's called a container image. What's fascinating about container images is that they are composed of overlapping layers. Each layer represents a change or addition to the file system. Instead of modifying data directly, changes are tracked by comparing them to the previous layer. The new system state is then formed by combining all the layers. This approach is similar to how source control tracks changes in your code. It's incredibly useful because it allows you to create custom images based on existing ones. Many pre-built, officially supported base images can be customized to fit your project's needs, adding your own code, packages, and configurations. To achieve this in Docker, we add the desired commands to a Dockerfile. Docker then executes these commands in sequence, adding each change as a new file system or metadata layer to the final image. We can run multiple containers from a single image. We can do this because when a container is created, the image's file system is extended with a new layer dedicated to that container. This allows us to make runtime changes without affecting other containers using the same image. Additionally, this new layer persists until the container is deleted, so we can stop and start containers without losing any data. You can also interact with running containers much like you would with a VM. For example, with Linux containers, you can start a shell prompt to explore the environment. Communication between containers is typically straightforward, as most container runtimes automatically virtualize the network layer for you. When your app is ready for release, you can tag it with something unique, like a version number for future reference. You can then upload it to a container registry, which acts as an online repository for your images. Docker uses its official registry by default, but you can use others if you prefer. For deployment, many cloud platforms offer built-in support for running containers as standalone units. Alternatively, you can install a compatible container runtime on any machine and pull your image from the registry you previously pushed to. This approach involves a few additional steps, but it often offers better cost efficiency and significantly more control. If you want to dive deeper into managing containers, orchestration platforms like Kubernetes allow you to set up your own container-based cloud environment. You define your desired state, and Kubernetes handles the rest, ensuring your containers run as intended. Please consider subscribing to the channel. We have a lot of exciting videos coming your way, and we wouldn't want you to miss them. Until next time.